You're at a red pedestrian light, watching cars speed past. Around you, a small crowd has formed, people also eager to finally cross the street. You find yourself wondering about the destinations, the current pursuits. Are they heading to work, meeting friends, or going on a date? Everyone is journeying towards something. They all have an objective, much like yourself. In the city, 500,000 people are leading their lives. Despite the fact that you'll probably never encounter most of these individuals, they all play a role in your life. Each person carries with them unique opinions, knowledge, and ideas. They are all conduits of information, receiving it, molding it to fit their perceptions, and then transmitting it onwards. Consequently, a complex tapestry of informational exchange is created, one that you are both a recipient and contributor to. Each dialogue held is a product of and influenced by previous exchanges. As you visualize this complex web, its sheer intricacy and the multitude of connections are almost incomprehensible. It's daunting, yet profoundly beautiful. Maybe even more interesting might be that such overwhelmingly complex systems can be created by very simple rules of interaction. In this case, let's simplify humans to mere actors. These actors can receive information, store information, create new information based on all received informations, and send informations. This phenomenon of complex new behavior arising from basic interactions of many constituents is generally called emergence. Across nature we find examples of emergence, from the collective behavior of atoms forming macro characteristics like temperature and the aggregation states, to flocking behaviors of birds and fish, or how the complex dance of firing neurons in our brains creates our conscious experiences. All these diverse systems share a simple principle. They comprise numerous individual parts that interact following specific rules. But these rules need not be complex. To exemplify the simplicity of these rules, British mathematician John Conway developed a computer model known as the game of life, a type of cellular automaton. In this model, cells on a grid exist in two states, on or off, alive or dead. The state of each cell changes according to a set of simple rules based on the states of its neighboring cells. From these rules, a vast array of structures emerge, none of which were explicitly programmed. No central controller or higher-level instructions are needed. They naturally emerge from the interactions of the parts. This also makes predicting emergent behaviors in general quite challenging and sometimes even impossible. In the context of emergence, this is known as irreducibility, as we cannot predict or compute the resulting emergent properties based solely on knowledge or its individual components. Now let's consider life itself, which can be viewed as a series of emergent layers. Atoms interact to form molecules, which in specific arrangements have the capacity to form proteins. These proteins, among other molecules, are integral to the functioning of the cells, the fundamental units of life. These cells in turn can differentiate and specialize, contributing to the complexity of multicellular organisms. Groups of specialized cells can form tissues which assemble into organs and other complex systems like the nervous and immune system. Collectively, out of the interplay, these components build an intricate functioning organism like yourself. But contrary to what this way of thinking about these systems might suggest, emergence doesn't simply unfold in a stack of independent layers. Instead, each emergent layer is not only created by the layers below, but also acts back on those levels, setting off a chain of novel behaviors across the system. Think about how organs evolved within organisms driven by the evolving necessities of the larger life form. Or as humans in terms of societies, our collective behavior gives rise to societal structures, which then guide and shape our individual behavior. The resulting dynamic of societal norms, technological advancements, and creative self-organization is an ever-changing interplay of different systems and layers. To understand these dynamics and even deliberately use them in our lives is a monumental task that might be necessary for our further development as a global society. But all this is a story for the next time.